Let's take a closer look at a paired sample t-test. This is also known as a dependent samples t-test. As with every other test that we've discussed, you start by stating your null and alternative hypotheses. They look a little different in the case of a paired sample t-test because we are concerned with the new variable d, which is based on the difference between paired values from the two data sets, where x1 is the value of the variable x in the first data set, and x2 is the value of the variable from the second data set that is paired with x1. The hypothesis looks like this, where mu d is the mean difference between the pairs. In most cases, you will likely hypothesize that there is no difference between the groups, but you could specify a difference in your hypotheses and test for that specifically. Next, of course, you select your confidence level and then you conduct your study. Once you have your data, you use this formula to determine if you have significant difference. In this formula, d bar is the mean difference between paired observations. To calculate this, you simply sum all of the d values obtained for the difference between each pair and divide by the total number of d values in your data. d0 is the expected difference. In most cases, this will be 0, but it could be any value. The denominator is the standard error of the differences, or d values. SD is the standard deviation of your d values, calculated in the exact same way that you calculate any standard deviation. Finally, the degrees of freedom are n-1 because the statistic is based on one mean. That is the difference between your matched pairs. So let's take a look at an example. Imagine that we have matched pairs where those people that are circled, are interacting with interface A, and the other in the pair are interacting with interface B. We are trying to determine if either interface results in less time on task than the other. As a result, we have a two-tailed hypothesis test with a significance level of 0.05. Our data looks like this. We calculate the differences between each pair, calculate the mean and standard deviation of those differences, and then we plug all of that into the formula for t-value of 0.2544. Given the small sample size resulting in a small number of degrees of freedom, I don't have to even check a t-table to determine if the result is statistically significant. I know it's not, and by now you probably recognize that as well. However, to formally draw a conclusion, the critical t-value for a two-tailed t-test with 7 degrees of freedom is negative 2.36, and our t-value is nowhere near that. There doesn't appear to be any differences in the interfaces in terms of time on task. Now, let's take a look at how we do this in Excel.